Hi guys, and welcome to what is going to be the final tutorial, episode 6 of our trail finding game in Python for the Microbit. So today let's get going at looking at creating a high score. We've already done one video where we dealt with the bug from last week and we finished off our game. What we're going to want to do now is we're going to want to create something that lets us save a high score. So when we get to the bottom of our code, when the player dies, their score is set back to 0. Apologies for this, by the way. I'm not sure why it doesn't let me highlight anything. It is a bit strange. So our score is going to set back to 0, but we're going to want to save what the high score was. And we're not just going to want to save what the high score was for now, because when you reset the device, that'll be lost. What we're going to want to do is we're going to write our high score out to a file, and then we're going to be able to read it back in another time. So the first thing we're going to want to do today is create a new variable to store our high score. And we're just going to say that high score is equal to 0, which makes sense because before we've checked whether there's an existing high score, if this is the first time it's run, the high score is going to be 0. Okay? Now what we're going to want to do is we're going to want to create a new function to state whether a high score already exists. Now, before we go any further, we're going to have to introduce two new concepts. I'm going to do this using my idle editor, which is just standard Python instead of MicroPython. Lets me just run this directly in the shell. And we're going to actually open a file that I have already prepared. No, we're not. We're just going to go straight off the bat. So let's save this. Let's just call it functions.py. Okay. So here I'm going to define a new function. I'm going to call it add. Okay. And add is going to print out a value of x plus y. Okay. Well, what is x and y? If I want to add two things together, I need to either say x equals 1 and y equals 2. Okay? And let's call the function. And what happens when I run it? Well, it's printing the value of 3. But what if I want to add up 4 and 5? I can't do that by calling this function. What I need to do is I need to be able to have a way of passing this x and y to the function. The way that I do that is using something called parameters. So let's create two parameters, x and y. And this x here will correspond to this x, and this y here will correspond to this y. And now inside of my call to the function, I'm going to put 3 and 4 in. Now 3 becomes x, which goes here, and 4 becomes y, which goes here. So when I run this, it's just going to print the value of 3 and 4. And I can change this value to be anything I want, and it will always run correctly. But now let's say that I actually don't want to print them out. I want to use the value of add 3 and 6. And I want to see if add 3 and 6 is equal to 9. Well, at the minute, when I run this code, okay, so at the minute when I run this code, I'm just getting this 9 printed. I can't check, even though I know the value of 3 and 6 is 9. I'm just printing it out. I can't give this back to here to test it. The way that I need to give it back is I need to do something called a return. And what return will do is it will replace whatever is here with whatever this is. And well, this would be a 3 plus a 6, since my x and y are 3 and 6, which is actually 9. So add 3 plus 6 is equal to 3 plus 6, which is equal to 9, if you understand that. It replaces whatever I have put here, this add 3, 6, it replaces with the actual function. So this logically is 9, is the value of 9. So when I run that, it's not going to print out anymore this, because I'm not printing x plus y. I'm testing whether x and y is 9. And these are two very important things, return types. A return well, what does a return type mean? Okay, can I say check if 3 and 6 is equal to hello, for example? What happens when I run that? Well, it will run, because what will happen is this string here will automatically be cast to an integer, to a number, and it might have done that using, well, let's say that we gave h a value of a, b, c, d, e, f, g, h, a value of 8 plus a value of 5 plus etc, etc. Okay, and we assigned numbers to the letters. Or we don't know how it's done it, but basically we know that this can't be equal. This is a string and this is a number. Those things can't be equal. A string is a collection of letters. Or alternatively, I could say here, I could say print hello. Okay, I could say print 3 plus 6, and I could say print 3 plus 6. And what's the difference there going to be between this one and this one? Well, when I run it, you can see I've printed hello. That's completely fine. It's a string. 3 plus 6, it's worked out that 3 plus 6 is 9 because it knows this is a number and it knows this is a number. But here, these quotation marks have dictated this is a string, and it will literally print out whatever is between those quotation marks. So there's a little tutorial, a little bit of information for you on how a function actually works. So here we're going to want to create a new function, and we're going to call it check high score. And all this function is going to do is it's going to check whether a high score exists. Before we can do that, we need to do something. We need to import the OS module, which is going to allow us to do one very important thing, and I'll explain that in just a second. So, if this is the first time your program has run, there isn't going to be a high score already. And how are we going to test whether there is a high score? Well, what we're going to do when we have a high score is we're going to write out to a text file what that high score is. That text file is going to be called highscore.txt. Okay? Before we can get that, we need to test whether there is a file on the file system called highscore. So the first thing we're going to do is we're going to get a list of all the files on the internal Microbit file system. The way we're going to do that is we're going to create a new variable files, and we're going to set its value equal to os.list directory. And that's just going to list the root directory. So here in my terminal, I can say ls, and that will list all the stuff in this directory here. Okay? And here you can see I've got my pictures, music, movies, blah, 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 blah. And I can look at all of these, and basically what I'm going to want to do is I'm going to want to do the same thing. I'm going to want to get these as a list and run through them one at a time. I'm going to say, is applications equal to highscore.txt? No, it isn't. Is RuneLoader equal to highscore.txt? No, it isn't. Is highscore.txt, for example, equal to highscore.txt? Yes, it is. I know I've got a high score, so I'm going to return a value of true. I'm going to tell them that it's true. The way we're going to do this is basically os.list directory is going to return a list. We know what a list is. It looks like that. And that list is going to have a number of strings in it. Each string is going to correspond to, well, let's say the microbit's got an info.txt, it's got a readme.txt, and it's got a highscore.txt. Okay? I need to be able to loop over these three and check whether they're equal to highscore.txt. Well, how am I going to do that? One way would be to say for I in range from 0 to the length of files, which, remember, that's just a loop that's going to count from 0, 1, 2. I could say if files I is equal to highscore.txt. Okay? I could say something like that, but we're going to use a different form of for loop today. So here I have an int. No, I have an int. This int is counting 0, 1, 2, and I use that to reference these objects: files 0, files 1, files 2. Instead of this, what I'm going to do is I'm actually just going to loop through those strings one at a time. The way I'm going to do that is I'm just going to say for f in files. That's going to say f is going to be equal to this, and here we're going to do something with it. It's going to be a string. So f is going to be, here, it would say, first f is equal to info.text. Then it will say f is equal to readme.text. And I really don't understand why it does that, but it's really annoying me, this editor. Next it will be readme.text. And then next it's going to be highscore.text. Okay? So the value of f is going to reference all of the files on the microbit. So here we're just going to say check whether the value of f is equal to the file that should hold the high score. So I'm going to say if f equals highscore.text, then we're going to return true. And we just literally say return true. Now, a return statement is always the last thing that is run in execution. So in this loop, if I find a file that is highscore.text, I don't keep looking through the rest of them. I've already found what I'm looking for. I'm going to return true. It's going to break execution of this. We're going to leave check highscore and we'll go back down to wherever we called it in execution. So what I'm going to need to do then is, if I haven't found the file, return false. And that's pretty simple. It's just return false, literally. So if the file is found, we'll return true, we'll stop looking. Otherwise, once we've looked at all the files, if none of them were highscore.text, we're going to say we didn't find it. Okay? Now, what's going to happen if we do find the file? Well, we're going to need a way of reading it. So define a function that reads the highscore in from the file. It's going to say define get highscore, and all that get highscore is going to do is we're going to use something called with now, and with is a bit complicated and you don't really need to know what it does, but we're just going to say open the highscore file, and we're going to do that saying with open highscore.text. Okay, and we're going to need to give this a flag. Now, a flag states what we want to do. R is saying we want to read the file. W says we want to write. B says we want to open it in binary mode, which means we look at the individual bytes that make up that file. And I'm not sure what text mode is. But basically, we want to open this in read mode because we're not writing anything to it. We just want to use it. Okay, and we're going to use that. We're going to say with open highscore.text, and we're going to set it as, let's call it highscore file. Okay, so with open highscore, so we're going to say whatever is returned from this, which is going to be something of type file. Remember, we can have a string, we can have an int, we can have a boolean, we can have a file. That's a custom type that someone has created, and that file will allow us to do different things. And all we're going to do with it is we're going to return whatever the contents of the file are, and we're just going to say, we're just going to read the file. Okay, return the contents of the file. And a very important thing to note is this has to be as an integer, otherwise we can't compare. So hs_file.read is going to return something of type string. So before we can compare that string to the current score, because we need to say every time our score goes up, we need to check whether it's higher than the high score. If it is, we'll update the high score, and if it isn't, then we won't do anything. But to compare those two, if one of them is a string and one of them is an int, then we won't be able to do it. So we're going to just use something called the int function to convert this string to an int. And since we're writing this code, I know this is always going to be an int. If we were passing in hello, for example, to that, it wouldn't work. We would get an error. But I know I'm always going to have an int in that file. And that's all we need. We're just going to return that. Okay? Well, what's the last thing we need to do to be able to, to access this? We need to be able to write to it. So define a function that writes the high score to a file. And the way we're going to do this is we're going to say define set high score. This set and get notation is very popular in a lot of other object-oriented languages, not so much in Python. There's a reason for that. I won't go into it, but it's mainly to do with the way that memory is handled. In Java, you have a concept of private and public memory, which means that some memory can be accessed and other parts can't. Whereas in Python, everything tends to be publicly available. So you don't have this concept of getters and setters as much. But basically, I'm going to get the high score and I'm going to be able to set the high score. And we're just going to say open the file we want to store the high score in. Okay, so we're going to do the exact same thing with open high score .text, and we're going to give it a write flag this time, and we're going to call it HS file again. We're just going to write the new high score to the file. So we're just going to say hs_file.write. Well, what we're going to write? We're going to write high score. Well, remember the use of global memory, that's not particularly nice in this situation. What I'm going to do is I'm actually going to pass the high score in as a parameter. Now by doing that, that allows me just to write HS out. But what if HS is an int and I've passed an int in? Well, I probably will be passing an int in, so I need to convert that to a string using this string function, which looks very similar to this int function. Okay, it's just ensuring that whatever I've passed in is made into a string before it's written to the file. And that's everything we need, funnily enough. Now we just need the logic that's going to actually update this. So the first thing we're going to do before we start our game loop is we're going to say check whether there is already a high score. Okay, so we're going to say if check high score, which will either be true or false, remember. So if check high score is true, effectively is what we're saying, then get the high score and store it in our high score variable. So we're going to say high score is going to be, currently it's equal to 0, and we're going to say high score is equal to, what's it going to be equal to? It's going to be equal to the value of get high score. Okay? So get high score is going to return an integer. So this is going to be equal to, well, initially 0, because we're not going to run this because we don't have a file when we first run it. When we do have a file, high score will become equal to whatever the previous high score was, whether that was 1 or 4 or whatever. Then we're going to display the current high score. Where we're going to do that is we're going to say display.scroll and we're just going to give it a string of high score. Okay, so that's it. That's letting us show the high score. Now we need a way of updating the high score. All we're going to do here is every time our score updates, when we come back into our loop, it's going to say if the score is greater than the high score, update it. So here's an example. We don't want to just update the high score when the player's finished playing, because the way they finished playing was normally going to be to unplug it, so we'd never write it. So all that's going to happen is, if the previous high score was 9, and this player hits 10, then the high score file will have a value of 10, and then we'll update it to 11 when they hit that, and then we'll update it to 12. We will always update it with the most recent high score. So let's just say if score is greater than high score, that's all we need to do, then set the high score set the high score equal to our score. We're going to need to both set our high score variable equal to score, but remember our use of pointers. We have a line here that sets score back equal to 0. So if I have a copy of this, it might set our high score back down to a value of 0. So I'm going to take a copy of this by using that int function. Just going to pass that in. And the last thing we're going to do is we're just going to say set high score And we're going to pass our high score variable in. And that's everything. It really is as simple as that. So let's get this flashed onto the Microbit. Recording now. And line 90. OS error. Okay, so we've had an error on line 98. And I'm not sure what is wrong there. That shouldn't be running the first time. Ah, there we are. We haven't made that function call. Okay, let's try that again. Never ever seem to get this swimmingly right first time. Okay, so let's have a look. There we are. So high score is 0, and then we're going to get our trail. And when I follow it, okay, so score is 1. Give me another one. Score is 2. Now let's just reset it and see my high score is now 2. What about if we unplug the device? Let's just quickly do that. I'm going to plug in my battery pack instead. Just give me 1 second. And when I reset the device, there we are. So we've kept it even after the power has gone. So, I hope you've all learned a lot from that today, guys. That's going to be the end of this tutorial series. I'm going to expand on this at a future date. And what we're going to do at a future date is basically, this way of doing things isn't great. What I'd rather replace it with is something called an object. We're going to learn some object-oriented programming. We're going to learn how to create something called a class. A class we're going to make is going to be something called a point class. And the point class is going to be something I set up, and we're going to learn how to do it. And you're going to be able to pass in something like a 0, 0. And that's going to create set p equal to a new point with a value of 0, 0, or 0, 1, let's say, okay? And what I'm going to do is I'm going to replace these here with these points. And then the way that you would call them is, instead of saying trail 0, 0, what you would do is I would call p.x. P.x will refer to this 0, okay? And p.y would refer to this. And we're going to learn a little bit about that. Might be with this tutorial, this trail game tutorial, might be with another thing. But we're going to look at some object-oriented programming and how that actually works. The other thing we're going to do is we're going to start a new game next week. And the new game we start next week is going to be something like this. Okay, let me just get rid of this here. You guys know how I hate for my Microbit to be messed up. Okay, let's pop that back to 10. So we're going to have a game, and the idea is we're going to have a player here, and the A button's going to make him go left, and the B button's going to make him go right. Okay, and we're going to choose a point at the top, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, and that's going to be our empty point. And the idea would be, if 4, 0 is our empty point, we'll fill these 4 in. Okay, and then they're going to advance towards our player. Okay, and the idea is, as they advance, our player is going to have to get over to here. Okay, so that by the time these guys hit, he's in the gap. And if he's not in the gap, we're going to die. Or something along those lines. We've got a fair few things to think about there. For example, if our player's here, can he loop round? Or is he stuck there and has to go all the way across? Can our player move can the player press 5 times to go over to here in one update of this? Or does the player need to press once to move there and then once again? So we've got a few things to think about there, but I think we're just going to try and create another game, just so you guys have really got in your head that these things aren't one-offs. You can really come up with some creative stuff for this, and you just have to be able to develop the ability to have an idea and then sit down and plan how you're going to do it. And that's what I'm going to do over the next week. I'm going to plan how to build that game. We're going to sit down next week and we'll start the second tutorial series. It'll be 2 episodes a week, again releasing on a Thursday until we get it finished. And we'll just keep introducing more and more concepts. So we might have menus, we might have difficulties, things like that introduced. I hope you've enjoyed this tutorial series. I've spent a good couple of hours on it now. I've really enjoyed building this. I hope you've enjoyed it as much as I have. As always, if you've any questions, any comments, just bob them under this video, send me an email, fire one over. I'm more than happy to help out. If you think there's any improvements to my code that I might have missed, please send me that as well. And we're going to have a link next week over to our next tutorial series. The first episode will be going up. You'll be able to link to it there, and obviously you can watch episode 5 by going backwards. Thanks so much for watching, guys, and I hope you've enjoyed it. Cheers.